Hello boys and girls, so in this video we are going to start our tutorial discussion on topic 13, gas law and kinetic theory of gases. In this video I'm going to focus on 13.1, ideal gas equations. So basically when we talk about gas, there are four macroscopic characteristics that we can measure in a laboratory. First one, amount of gas. Normally we represent by the numbers of mole, small capital N. So the numbers of mole we might determine from the mass of the gas, M, divided by the molar mass, capital M. The molar mass can be obtained from the periodic table, but bear in mind, we need to change it to unit kg per mole, alright? Second one, pressure. Pressure is referred to the force per unit area that gas molecule exert on the wall of their container. So 1 atmospheric pressure, 1 atm, is equivalent to 1.013 to the power of 5 Pascal. Now we can measure the volume of the gas. Volume of the gas normally is referred to the volume of the container. Okay, because our gas didn't have any fixed shape, but gas will occupy the volume of the container. So the volume of the container actually is the volume, referred to the volume of the gas. So 1 liter is 1 to the power of -3 meter cube, because all our calculation must in SI units. So bear in mind, if the volume is given in liter, we have to convert it to meter cube. Then the third macroscopic characteristic that we can measure, we can observe for a gas is temperature. Usually we measure it in degrees Celsius, but then we need to change it to Kelvin, whereby when we describe about gases, we are considering the absolute temperature. Okay. So how to change degrees Celsius to Kelvin? So bear in mind, Kelvin is degrees Celsius plus 273.15. Okay, so this is the four macroscopic characteristic that we can observe for a gas, that we can see with our naked eye. Okay, we can measure it. So basically we know that we have three gas laws. First one, Boyle's law. Second one, Charles' law. And the third one is pressure law, Gay-Lussac law. According to Boyle's law, the pressure of a fixed mass of gas at constant temperature, you will find out that the pressure is inversely proportional to the volume of the gas. So if we sketch the graph, so when our volume increase, when the volume of the gas increase, we will find out that our pressure will decrease, inversely proportional. Alright. So inversely proportional, when our volume increase, our pressure will decrease. So PV equal to constant. So if we have initially the pressure is P1 and the volume is V1, after some changes, we might have final volume V2 and P2. So how we are going to relate the initial condition and the final condition? We will have P1 V1 equal to P2 V2. Second law is Charles' law. According to Charles' law, the volume of a fixed mass of gas at constant pressure is directly proportional to temperature. Okay, so volume for constant pressure, the volume of a gas is directly proportional to temperature. So V over T will be always constant. So if you plot graph volume a gas temperature, when temperature increase, the volume of the gas will increase. Okay, you will get a straight line, start from 0 Kelvin. Okay, we plot graph for absolute temperature. The scale is in Kelvin. So How we are going to relate the initial condition and the final condition? We might have V1 over T1 is equal to V2 over T2. Always bear in mind, 1 refer to the initial condition, 2 refer to the final condition after we do some changes. Alright. The third gas law that we might have is pressure law. So, providing that if our volume is constant, we will find out that for a fixed mass of gas, the pressure is directly proportional to temperature. So, P over T is always a constant. So, if we plot pressure against temperature, we will find out that direct proportional means when our temperature increases, the pressure will also increase. Okay, we will get a greater pressure for a greater temperature. So, how we are going to relate the initial condition with the final conditions? We have P1 over T1, the value must always equal to P2 over T2. Alright, so this is the 3 gas law. Then, we might combine the 3 gas law into a single general relation that will relate pressure, volume and temperature for a fixed quantity of gas. So, right in mathematic forms, we have PV over NT always is a constant value. So, how I'm going to get this constant value? So, everyone understood that for 1 mole of any gases, doesn't matter what gas, you might have 1 mole of hydrogen gas, you might have 1 mole of oxygen gas, or you might have 1 mole of nitrogen gas. But if the gas at standard temperature and pressure, STP, whereby our temperature is 273.15 Kelvin and the pressure is 1 atm, 101.3 kilopascal, we will find out that all the gases will occupy a volume of 22.4 liter or equivalent to 22.4 decimeter cube. Deci means times 10 negative 1. Okay, sorry. So, class. So, we take the equation PV over NT is always a constant value. Then I put in the value for the condition at standard temperature and pressure. So, the pressure is 101.3 to the power of 3. The volume occupied is 22.4 decimeter cube. I change it to meter cube times 10 negative 3. So 1 mole of gas, so the N is 1, the temperature is 273.15. Then when I do my calculations, I will obtain that the constant value will be 8.31 joule Kelvin minus 1 mole minus 1. So the value of 8.31 is found experimentally same for all gases. So we call this value as molar gas constant. Capital R. We denote by capital R. Okay. So no need to memorize for the value. It will be given in the list of constant. Okay. So R, this constant is represented by R. We call it as molar gas constant. The value is 8.31 joule per Kelvin per mole. So guys, we have what we call ideal gas equation. So generally for a fixed quantity amount of N mole gas occupy a volume of V at pressure P and absolute temperature T, we can relate all these macroscopic characteristics using what we call ideal gas equations. PV equal to nRT. But bear in mind, our pressure must measure in Pascal. Our volume must measure in meter cube. Numbers of mole in mole. R is the molar gas constant, 8.31. The temperature is the absolute temperature. Absolute temperature means the unit must be Kelvin. Okay, the unit must be Kelvin. So if a problem didn't give us the unit in all these SI unit, then we have to do the unit conversion lah, class. Bear in mind. Make sure you have make sure all these variables are in SI unit before you can use the ideal gas equation to solve the problem. Then class, I just recall your prior knowledge how to calculate the numbers of mole of gas. So the numbers of mole of gas we might determine from the mass of the gas, whereby the numbers of mole is mass of the gas divided by the molar mass of the gas. Or we might also relate the numbers of mole with the numbers of molecule. How many molecule, how much molecule or how many molecule we have in a certain volume. So the capital N represent the numbers of gas. We might take the numbers of gas molecule divide by the Avogadro constant. So the value of Avogadro constant is 6.02 to the power of 23. So we might also can determine the numbers of mole. So class, because we can relate the numbers of mole with the numbers of gas molecule, so the ideal gas equation can be also written in terms of numbers of molecule that presents. So we have the ideal gas equation PV equal to nRT. So the N I'll replace with N over Na. N over Na. Okay. R is molar gas constant. Na is the Avogadro constant. So R over Na, I can represent it with a constant I denote by small capital K. So the K is what we call Boltzmann constant. So when I do the calculations, I'll get the value of K is around 1.38 to the power of 23 joule per Kelvin. Okay, so this value is what we call Boltzmann constant. No need to memorize, will be given in the list of constant. So I might write the ideal gas equation in terms of numbers of molecule. Okay, in terms of numbers of molecule, whereby we have PV equal to NKT. So this is another form of ideal gas equation, but providing that we relate with the numbers of molecule. We relate with the numbers of molecule. Okay. So basically ideal gas is a hypothetical perfect gas that which will obey all the gas law lah, over all pressure and also temperature. So class, before we proceed to another new concept in this topic, let us try tutorial 13 question 2 together.